Okay, so this is use isosceles and equilateral triangles. So we talked about isosceles and equilateral triangles at the beginning of this chapter. So this should be a real quick review, and we're going to add a little piece to it. So isosceles triangles, we have a vertex angle, we have two legs, and the legs are the two equal sides, because isosceles triangles by definition have two equal sides, right? And they also have this side, which we call a base. And because this side is the base, these two angles right here are called base angles. Okay? So the new thing is that every isosceles triangle has two congruent legs, but the new thing is it has two congruent base angles. So this angle right here is congruent to this angle. And the reason that is actually because of these two congruent sides. So this side is the opposite angle of this leg, and this is the opposite angle of that leg. Because they're opposites of each other, since this one's congruent to this one is congruent to this one. Okay? So let's take a look at example 1. I'm just going to use that fact. And of course in geometry, if this relationship exists this way, since these two are congruent, we know that these two are congruent. That means we also know it the other way, right? If we know that these two angles are congruent, then these two sides must be congruent. All right. So going back to example 1, it says complete the statement. If side AB is congruent to AC, then what angles are congruent? So here's AB, here's AC. Well, we can see that B must be congruent to C because this angle is opposite this one, this angle is opposite that one. So angle B must be congruent to angle C. All right. So of course in math, never stays that easy. We got to enter in some variables. So let's take a look at example 2. Example 2 says find the value of x. All right. So here we have this triangle, and we have this side congruent to this side, which means we have an isosceles triangle, right? But we have this 3x plus 5. And that's supposed to be this angle here. Well, like we just said, since it's an isosceles triangle, this is the opposite angle. This angle as well must also be congruent to that angle, right? So if this is 3x plus 5, that means this angle over here is also 3x plus 5. So I now know the measurements of all three angles. I have 1, 2, and 3. And what do we know about the measurements of angles inside of every triangle? Well, every triangle's angles add up to 180, right? So I'm going to say 180 is equal to 3x plus 5 plus 3x plus 5 plus 50. Okay? So all of this is equal to 180. Let's simplify things. 3x and 3x is equal to 6x. 5 and 5 is 10. 10 plus 50 is 60, right? And if we're going to solve, let's just go ahead and get x by itself. 6x is equal to 120. Well, in order to find out what x equals, I need to divide by 6. So x is equal to 20. Okay? So again, you're going to have some problems where it puts the x in the angles. You're going to have some problems where it gives you that the angles are congruent, but you're going to have to find the sides, and the x's will be on the sides. But we know that if the angles are congruent, then the two opposite sides must be congruent, right? So the only other piece we have to learn today is equilateral triangles. And again, every equilateral triangle has 3 congruent sides and 3 congruent angles. Remember I talked about this at the beginning of the year. If you know that all 3 sides are congruent, you know that all 3 angles are congruent, because the other name for that kind of triangle was an equiangular triangle. But like I said, you never really see that much. They always call them equilateral triangles, and it's because they are the exact same type of triangle. Okay? But I did put 60 degrees down here, and the reason I did that is because if the angles are all congruent, that means we have 180 divided by 3, which means every angle is 60 degrees. Okay? So let's take a look at example 3. How are we going to use that? Well, it says find the perimeter of the triangle. And again, perimeter just means the length of each side, right? Added together. So if I want to walk around this triangle, that would be the perimeter. So again, looking at the triangle, we see that we have all three angles congruent. And since all three angles are congruent, we have an equilateral triangle, which means that all the sides are congruent. So if we know that all the sides are congruent, I can set up an easy equation to solve for x, right? And once I know x, I can just plug it back in and figure out the perimeter. So I'm going to say x plus 3, that side, is equal to this side. Okay. Notice I didn't use this one, but actually if I want to, I could go ahead and use that one. So I'm going to say 3x minus 3 is equal to 4x minus 6. Doesn't matter what side I pick, because I have 3, I can pick any 2 that I want, but as long as I pick 2, I should be able to solve for x. So let's give this a shot. I'm going to subtract x, get the x's over here, which means I'm going to take my numbers and move them over here. This is 3x, and this is 9. Well, that means if I divide by 3, I get x is equal to 3. Let's double check it over here just to make sure. I'm going to subtract 3x, and I'm going to add 6. This equals x, and negative 3 plus 6, well, that's equal to 3 as well. So you can see that I get x equals 3, but I'm not done because it says find the perimeter of the triangle. So now I have to plug that x value back into one of these equations, or one of these values, these expressions. And looking at it, I think this is the easiest one to plug it in, because we just proved that they're all the same length, right? So it doesn't matter, I don't have to plug it into each one, I can just plug it into one and do what? I can take that number and multiply it times 3, right? Because there's 3 sides, that'll give me the perimeter. So x plus 3, well, x plus 3 we just said is going to be 6, right? So if each side length is 6 and there's 3 sides, I just get 3 times 6. 3 times 6 is 18. So the perimeter of my triangle is 18. All right, so the problems you're going to be dealing with are pretty much in that form. There is going to be a proof, but don't worry about it. It's not that much harder than any other proof you've been dealing with. So good luck.